Okay, for some, this is a quick review. For others, this is the first time you're exposed to this. So Pascal's Triangle is this cool tool that you can use to quickly expand binomials raised to a certain power. So what you guys have been doing up to this point is if you have x plus y squared, most of you think, oh, we can just do the FOIL method. Well, once it's higher than the exponent is other than 2, you can't use the FOIL method. So it's a lengthier process. But with this cool Pascal's Triangle method, you can quickly come up with how to expand, what the results when you do the operation. So here's Pascal's Triangle. Just looks like a bunch of numbers. And notice we have 1 at the top. The next level is 1 and 1. And what it is, the rows, you look at the two numbers directly ahead of you, above, and you add those two numbers. So I don't know. I do know I'm not explaining this very well. So let's come down here to the bottom level. So let's look at 1. Notice the two numbers that would go directly, it would be between, would be this invisible number, 0, and 1. 0 plus 1 is 1. Let's look at 7. Well, 7 is between 1 and 6. 7, 21, 6 and 15, 35 is between 15 and 20, 35 is between 15 and 20, 21 is between 15 and 6, 7 is between 6 and 1, 1 is 1 and that invisible 0. So that's why there's all these 1s on the outside, because it is just below a 0 and a 1, a 0 and a 1, a 0 and a 1, so forth. So that's how you would arrive. Let me erase some of this stuff so it doesn't look so crazy. And what Pascal's Triangle, here, I'm going to erase all of this. It tells us how to expand binomials to a certain power. So this would be a binomial squared. This would be a binomial cubed, a binomial to the 4th, and a binomial to a 5th. Well, this would be a binomial to the 1st, and this would be a binomial to the 0, which is any non-zero number to the 0 exponent is 1. So we're not ever going to use that, but it's good for you to know. All right, so the numbers that are in each row are the corresponding coefficients. So let's look at x plus y squared. So x plus y times x plus y, x times x is x squared, x times y is xy, y times x is xy. Well, there's 2 of those, so that's 2xy, and then y times y is y squared. There's an invisible 1. Oh, look at that. 1, 2, 1. 1, 2, 1. And if it would have been a cube, then it would have been x cubed plus 3 and some stuff plus 3 and some stuff plus y cubed. So let's think about what the stuff is. So if this is x cubed, so here's x squared, this is x to the 1st. This is y squared, this is y to the 1st. So look at, the powers of x go descending, the powers of y go ascending. So if this is x cubed, this is going to be x squared. And right here, this would be y to the 0, so this would be y to the 1st. Now this was x cubed, x squared, so this will be x, this will be x squared. Oh, look it, and y cubed. So it's a pretty nifty thing that you can do with Pascal's Triangle. Instead of doing it the route that I had to do when I was in high school, you get to do it a much faster method. So here's x plus y to the 4th. So the first term, x to the 4th. plus, so look at the row, Pascal's triangle, 1, 4, 6, 4, 1. So this is what we want to focus on. So x to the fourth. So then there's that invisible 1 right there, an invisible 1 right there. So we have 4 on the outside of parentheses. Now it's going to be x to the third, y to the first. And now we have a 6, so plus. The reason all these are pluses is because there's a plus sign here. So plus 6. Now we're going to go descending for the x's. So x to the fourth, x cubed, x squared. Ascending for the y's, x to the first, x squared. Plus, now we're back to 4. 4, x to the fourth, third squared, x to the first. Y to the first, second, y cubed. And then finally, plus 1, y to the fourth. So if you were to just simplify that, x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. And we will be practicing this quite a bit. You don't have to have all of this memorized in a 4-minute video, but it's a very handy tool. You can use Pascal's Triangle for other things, but this is where we're primarily going to use this. All right, that's it.